we're going to take the idea of similarity and push it further and talk about how we can prove that two triangles are similar. We've already proven that two triangles can be congruent, and we have those theorems that we can refer back to. We also have theorems that we can use to show that two triangles are similar. It is important to note, though, that similar triangles and congruent triangles, they're completely different. So when we talk about similarity theorems, we have to make sure that we specify that it is a similarity theorem and not a congruence theorem. So just like with congruent triangles, so to recall, when we talked about congruent triangles, we said that corresponding parts had to be congruent. The corresponding angles and the corresponding sides had to be congruent. When we talk about similarity or similar triangles, there is one key difference. The corresponding angles still have to be congruent. So corresponding angles are congruent. But when it comes to the corresponding sides, those are proportional. So if that's the case, then the two polygons are similar, and we're going to focus on triangles. So instead of getting out rulers and protractors and trying to draw all of this, I have a sketch pad open that we're going to look at, where I have all this laid out. So here I have that information. I have triangle ABC, where angle A is 30 degrees and angle A is 50 degrees and angle B is 30 degrees. And I have triangle DEF, where angle D was 50 degrees and angle E is 30 degrees. Now, the measurements are there for us to fill in the table below. So, as we know, in a triangle, all the angles have to add up to 180 degrees. So that means if angle A is 50 and angle B is 30, that means angle C has to be 100, because 100 plus 50 plus 30 equals 180. And if you look at the other triangle, angle F has to be 100 degrees as well. So then the ratio of angle C over angle F, so 100 over 100, that equals 1. Now AB, let's see how long AB was in that drawing. AB is 4.7. Segment DE is 6.8. Segment BC is 3.7. EF is 5.3. So you may be asking, where did I get these lengths from? These lengths were just created when I made the two triangles with these angle measurements. What I did here was I just made two triangles where I had one angle that was 50 degrees and an angle that was 30 degrees. And whatever the side lengths ended up as is what they ended up as. I didn't measure anything to make sure that they were, these exact numbers. I just created these triangles with the angles measures in mind. So AC is 2.4, and FD was 3.5. So now what we're going to do is we're going to take these values and see what we get when we write them as fractions. Okay, so 3.7 over 5.3, 2.5 over 3.5. So when I get the calculator out and I type in these ratios, okay, the first one is 0.69. When I do 3.7 divided by 5.3, I get 0.698. When I get 2.5 divided by 3.5, I get 0.71. So they were all around 0.7. If we were going to round to the nearest tenth, they would all be 0.7. Yes, they were off a little bit, but they were pretty close to each other. So we're going to say 0.7 for all of them. So since the side lengths have the same, or the corresponding side lengths are proportional and they're all the same, you get 0.7, 0.7, 0.7. So are these two triangles similar? Yes, they are. Because the side lengths are proportional. And again, you may be saying, well, they weren't exactly 0.7 all the way down. Well, the software isn't perfect. When I draw things and measure them with the software, the way that the software can round the numbers is a little bit off. So that could mess up my ratios. If you were measuring this with a protractor or ruler, you might find the same issues. So the only information that we absolutely knew was that two angles in one triangle were congruent to two angles in another triangle. Just based off of that information, we were able to prove that these two triangles as a whole were similar to each other. So if two angles of two triangles are congruent, then the triangles are similar. Oops. The triangles are similar by angle-angle similarity. And remember, we didn't have angle-angle congruency or angle-angle-angle congruency, but for similarity, we do have angle-angle. And you don't need to say angle-angle-angle because if we know that two angles are congruent, that means the third one must be congruent as well, like we saw here. One angle, we had angle A and angle D were 50 degrees. Angle B and angle E were 30 degrees. So angle C and F must be 100. So we don't need to explicitly say angle, angle, angle. It's implied by just saying the two angles. So let's go on the next page. Can we prove that these triangles are congruent by angle, angle? So just like with congruencies, I'm going to get my colors out and underline the corresponding parts. Okay, so angle T and angle J both had one angle marking, so I underline those in green. Angle U has 2 and angle K has 2. So those two angles are congruent to each other. So we have angle, angle already. And then I can do purple for letters V and L. So now I just got to make sure I go in the correct order. So triangle JKL is similar. That's what this symbol means right here. Remember, similar to triangle. Well, we got to go in the same order. J was green, so I have to go with green here. T must come first. Then K was blue, So then I must go to U, and then that means my last one must be V, because L is purple and V was purple. So again, the order does matter. If we look at number 2, we do have vertical angles, and we still need to worry about those. So 1, 2, 3, 4. And the reason I'm putting 4 markings is because we already have an angle with 1. We have an angle with 2 right here at letter F. And we already have angle G that has 3 markings. So, like I said before, if I just put 1 marking here, that's saying that these 2 angles at E, that these vertical angles, are also congruent to angle C. And we don't know that to be true. So we have to have a different number of markings there. All right, so now I'm looking at this, and I have one congruent angle, angle E, but angle C is not congruent to angle G or F. And angle B, there's no markings there, so angle B is not congruent to angle G or F. So these 2 triangles are not similar. There's not enough information. We would need to either know that angle C was congruent to angle F or G, or angle B was congruent to angle G or F. But we don't have that information here. All right, now number 3, we have vertical angles again. So these 2 angles are congruent, angle H, and angle T and angle G are congruent because they're both 61 degrees. So we do have angle this time because angle T is congruent to angle G, and angle H is congruent to angle H in both triangles. So let's just make F and S blue. So now we can write our similarity statement. So H was pink. So we have to start with the pink one in the second triangle, so H. And then G comes next, which is green. So that means T must come next. And then F is last, which was blue. So S must be there. Oh, I forgot the triangle symbol. Let's just add that. Okay, so angle is the first similarity statement. It's probably the easiest one to recognize because you don't really have to do much math to figure it out. Now, the next one we'll talk about is called side-side-side similarity, which is different than side-side-side congruency. And there's a difference. You can't just say side-side-side because I don't know if you're talking about congruence or similarity. So, if the corresponding sides of 2 triangles are proportional, then the triangles are similar by side-side-side similarity. And the way we write that is we can write side, 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 or SSS, and then the similarity symbol after it. That is how we can differentiate between side-side-side congruence and side-side-side similarity. And this one might seem pretty obvious, just like how side-side-side congruence I called the oh-duh theorem, and it should make sense that, hey, if I have 3 sides that are congruent to 3 sides of another triangle, of course the triangles are congruent. The same idea here, if I have 3 sides that are proportional to 3 sides in another triangle, then they should be similar. But we have to do a little bit of work to prove that. So in example 1 right here, it says, is either triangle DEF or triangle GHJ similar to triangle ABC? So what we want to do is take our triangle ABC and see if this triangle DEF is similar to it or triangle GHJ. We're not going to try to compare triangle DEF to triangle GHJ. We're comparing triangle ABC to each of them separately. So what we want to do is we want to write out what the similarity statement would be. We're going to say, hey, let's pretend they are similar. What would that look like? So what I like to do is I like to start with, the one I'm going to be comparing to, like the main one, which in this case is triangle ABC. So I take the smallest side of triangle ABC, which is AB, and say, okay, let's do AB over the smallest side and triangle DEF, which is DE. That should equal, and then I'm going to go to the next largest side. So it's BC over EF. And then that should also equal, and I'll go to the last ratio, AC over DF. Now, one of the common questions is, well, does it have to be written this way? Could I have DE over AB, EF over BC, and DF over AC? Yes, you can do that as long as you're not mixing and matching. Okay, you can't have AB over DE and then on the next, my light blue, flip it. The top number in each of my fractions is from triangle ABC. Now let's fill in the actual values. AB is 8 and DE is 4. Now the light blue, BC is 9 and EF is 6. And AC is 12 over DF is 8. Now these don't look similar, but let's simplify these fractions. If we simplify them, 8 over 4 is 2 over 1. 9 over 6 is 3 over 2. And 12 over 8 is also 3 over 2. Well, these two are the same, but since all three of them are not the same, these are not similar. Not similar. All right, now let's do the same thing with the other triangle. So I'm going to use the same colors. AB was red, so the smallest side in that other triangle, the last triangle, is HG. Okay, then I'm going to go to light blue again. 9 is the second longest side or second smallest side. JH is the second shortest side in the other triangle. And then that should equal AC over JG. So then we're going to, again, replace the side lengths with replace the labels with the actual side length. So AB is 8. HG is 16. That should equal BC, again, is 9 over JH, which is 18. And that should equal 12 over 24. So when we do that, it will simplify. 8 over 16 is 1/2. 9 over 18 is also 1/2. And 12 over 24 is also 1/2. So all three of these are the same. Whoops. So these triangles are similar by side. So we got to write a similarity statement. So triangle ABC is similar to triangle, and we got to make sure we go in the right order. So AB, is my red line here, and A touches the green side and B touches the blue side. So we got to do the same thing over here. So we got to go GHJ. And we got to say by side similarity. So you have to check all of them. You can't just check 2 of them, because if we just did that for the first problem right here, had got 3 over 2 equals 3 over 2, you might have said, oh, yeah, okay, these are similar. But yet it has to work for all three. And it did over here. It worked for all three of them. Now, in example 2, there's a couple ways you can solve this one. It says, find the value of x that makes triangle ABC similar to triangle DEF. So I noticed that BC and EF are corresponding parts. So BC over EF. And the reason I want to highlight those is because you have numbers there. You don't have any variables. You don't have to figure something out. It's just there. You have 4 over 10. So now I want to find another pair of corresponding sides. And it doesn't matter what you use. I'm going to use AB and DE. You could do AC and DF instead, and you'll still get the same answer. So now I'm going to set up my ratios. So 4 over 10 equals x minus 3 over 20. Now there's some danger coming up when we cross multiply this. Okay, so we'll get 80 equals, when I do the other loop, the 10 and the x minus 3, you got to multiply the x and the negative 3 by 10. So that's what it would look like. And then you would distribute. So 80 equals 10x minus 30. Add 30 to both sides. Add 110 equals 10x. And then when you divide both sides by 10, x is going to equal 11. And if you would have used AC and DF instead of AB and DE like I did, you would still get x equals 11. And then the last one here is like example number 1, but we're not comparing just to one of the triangles to say which of the 3 triangles are similar. So we're going to have to look at this red one and compare it to this green one and the purple one. And then we're going to also have to compare the green one to the purple one. So we're actually going to do 3 comparisons. So what I'm going to do is I'm going to highlight or mark all my smallest sides in red. So I know that those will go together in my fraction or my ratio. And then green for all the second smallest sides. And then for the longest sides, I'm going to do blue. So now it's going to be a little bit easier for me to set up. So I'm going to work with I am triangle 1, 2, and 3. So for I'm going to do first 1 and 2. So 18 over 30, that needs to be equal to 21 over 35. And that needs to be equal to 27 over 30, and 27 over 45. So again, I put everything from triangle 1 on the top and everything from triangle 2 on the bottom of my fractions. You could reverse that, put everything from triangle 2 on the top, and you would still get the same answers. When we reduce 18 over 30, we get 3 over 5. When we reduce 21 over 35, we also get 3 over 5. And when we reduce 27 over 45, we also get 3 over 5. So these two triangles are similar by side-side-side similarity. So let's write the congruent statement. Let's write the similarity statement, I mean. So triangle X, Y, Z is similar to triangle, we got to go in order now, X, Y, Z, so I go from red to green to blue. So it's got to be Q, R, P, red to green to blue, the same order, by side, side, side similarity. Well, because triangles 1 and 2 are similar, that means I only need to check triangle 1 compared to 3 or triangle 2 compared to triangle 3. Because since triangle 1 and 2 are similar, they're either both similar to number 3 or they're both not similar to number 3. So let's do, for the sake of dealing with smaller numbers, let's do 1 and 3. So we'll have 18 over 38, and that needs to equal 21 over 42, and that needs to equal 27 over 54. So 18 over 38 is 9 over 19. 21 over 42 simplifies to 1/2, 1 over 2. 27 over 54 also simplifies to 1 over 2. So these are not similar because you do not get the same result each time. So that means we don't need to check triangles 2 and 3. So again, color coding things is going to make things a lot easier for you guys. Just make sure you have enough colored pencils or markers or whatever you need to color code that, and then you're just matching things up and reducing your fractions. So thanks for watching. Make sure you smash that like button and subscribe.